Okay, so here is lesson B5. We're on page 14, and this is about average and instantaneous rates of change. Okay, so let's just write two things up here real quick. So AROC over an interval AB. So AROC is average rate of change, and that always happens over an interval. So we talked about last time how this would be f of b minus f of a over b minus a. And what this is, another way of looking at this is I'm going to use m for slope. This is the slope of the secant line. Okay, and I'll show you in a moment what a secant line is. Actually, I could refer to it down here. So I drew two lines here. So I colored this one green and this one blue. The blue line is called a secant line. So maybe down here we'll just say, so the blue is a secant line because it hits the graph twice. The green one is what is called a tangent line. So that is just hitting the graph at one spot. It's not like cutting through it twice. It's just, just touching it here and then, but never really cutting through it. So that's the difference between a secant and a tangent. So average rate of change, AROC, is this formula, which is the traditional slope formula, and that's the slope of the secant line. Now, instantaneous rate of change, that will abbreviate as IROC, and this is happening at an instant, not over an interval. So IROC is going to happen at one instant or one number, and this is the slope of the tangent line. Okay, so down here, given the sketch of f of x, part A, find the average rate of change of f of x over the interval 2 to 5. Okay, so this is AROC. So part A, so AROC is going to be f of 5 minus f of 2 over 5 minus 2. And you could see from the graph, so the f of, those are the y values. So f of 5 is 9 minus f of 2 is 7 over 5 minus 2 is 3. So 9 minus 7, okay, so 2/3. Okay, so the average rate of change over 2 to 5 is 2/3. Now, the instantaneous rate of change is the slope of this tangent line. So this is going to give us the rate of change at the x value, x equals 2. Okay, so for this one, this is part B, we'll just do y minus y over x minus x for these 2 points. So this is going to be 12 minus 7 over 4 minus 2. 12 minus 7 is, so 5 over 2. Okay, now this thing here, which is the instantaneous rate of change, IROC, slope of the tangent line, another name for that is the derivative. All right, the derivative. So for part C, they say state your answer to part B in both prime and Leibniz notations. Okay, so Leibniz notation is just named after a certain mathematician a long time ago who, did a lot to advance calculus, and, I guess he came up with this notation. And depending on the context, guys, one notation might be preferable over the other. Prime is a lot shorter, but sometimes Leibniz can work better depending on the situation. So this is part C. So prime, and then Leibniz. We'll just go like that. Okay, so in prime notation, part B is f prime of 2 equals 5/2. All right. In Leibniz notation, it goes dy dx. Okay, so think of like delta y over delta x, that's like a way we think of slope. And so this notation is kind of based off of that idea. So dy dx, and then you do a little line. This means evaluated at, and then down here we'll say x equals 2 equals 5/2. And this is just notation. This is just symbols and, how we read them. Okay, guys, prime Leibniz. Now down here, draw a sketch to represent the average rate of change of f of x over, we got to change these, over the interval c to x. Okay, so let's just draw like a little picture. Let's say that this is c, and let's say that this is x. And I'm just going to do like a simple, let's do it like something like that. Okay, so here is f of c. All right, so yeah, so the y values, this here would be f of c, and this up here would be f of x. And draw. I just need like a straight edge, sorry. Okay, and then I'm just drawing a line through those. Make it blue. Okay, so right there. So the slope of this, so this is, so the slope of this secant line, that is equal to the AROC over c to x. Okay? All right, so that was the first part, drawing a sketch. So that's what we did. Write a formula for the average rate of change of f of x over the interval c to x. So that would be, I'll just say equals because this is all the same thing. So that's f of x minus f of c all over x minus c. So what we're doing here, guys, is developing a formula that we're going to be using a lot. Okay, so maybe we should label these A, B, and C. All right, so this was part A. This here is part B. And then we're going to have a part C in a moment. So part C, write a formula for the instantaneous rate of change of f of x at x equals c. So guys, what you do is you take your average rate of change, so this line here, and what we want to do is instead of the slope of this blue line, what we want is the slope of, I'll color this green, so let's just draw a tangent line here. Whoops. What we want is the slope of this tangent. All right, so the slope of that tangent line, that would be the instantaneous rate of change. And the thing is, guys, is that if you take the average rate of change, but you make it so x just keeps getting closer and closer and closer to c, then this secant line is going to approach this tangent line. So this, you'll have the slope of the secant line, but as x gets closer and closer and closer to c, it becomes the slope of the tangent line, and that is the instantaneous rate of change. So what you do, so we'll say f prime of c, okay, that's the instantaneous rate of change in prime notation at c, is equal to the limit as x approaches c of f of x minus f of c over x minus c. So we're going to be using this formula here to find the average rate of change, or the instantaneous rate of change. And a couple days from now, guys, we will have a big shortcut to using this formula. So let's do one example here. Okay, so use a limit to find the instantaneous rate of change of f of x, which is equal to x to the third, at x equals 4. Okay, so guys, I just want to contrast a couple things. So here, let's do, all right, so if you're ever having trouble remembering the formula, you could go like this. You could think of instead of doing the IROC at x equals 4, you could think of the AROC over whatever number you want the IROC at. Have your interval start there, and then end your interval at x. Okay, so this is like if you ever forget the formula. So the AROC over the interval 4 to x would be f of x minus f of 4 all over x minus 4. Okay. And then, so AROC is like easy to remember. And then, so the IROC, the difference between IROC and AROC is that this interval, instead of an interval, you're shrinking the interval down to one single value, which is 4. So the IROC at x equals 4 would be the limit as x approaches 4. That's what's going to make this interval shrink down to a single instant. And then the AROC just goes in here. So IROC is really like the limit of the AROC. Okay, just like that. And now we're gonna plug these things in. So this is equal to, and if you're in physics, calc-based physics, this will be cool because you'll see at the end we're gonna get something that you might know a formula for already or a shortcut for already. Okay, so f of x is x cubed. F of 4, if you plug 4 in there, you get 4 cubed, which is 64. And then this is all over x minus 4. Okay, so you're doing this limit. So you try direct substitution. And when I do direct substitution, I end up getting 0 over 0. So this means I have to do algebra. So I could factor the top. That's a difference of 2 cubes. Okay, so in the top we have x minus 4, and then x squared plus 4x plus 16 all over x minus 4. Okay, now we got to be careful with notation. So can this be simplified further? Yes. If the answer is yes, then you need another limit. Your last limit has to have the simplest possible form. All right, so x squared plus 4x plus 16. Okay, so then this is 16 plus 16 plus 16. All right, yep, it's 48. Okay, guys, there it is.